In section 2.2, we are going to try to add to our first degree equation solving skill set by giving you some tips in how to deal with equations involving fractions. First thing we could do is say that we don't actually need any different strategies if we're very comfortable with fractions. Really nothing has changed. Just because there are fractions doesn't change the addition property of equality or multiplication property of equality. So if we wanted to, we could simply charge ahead and say, all right, well, I'm going to get rid of minus 2/3 by adding 2/3 to cancel that out, right? And that's going to leave us n over 2 equals, but now we got to do 5/6 plus 2/3, and we know in order to accomplish that, we would need to get a common denominator. So that's going to leave us n over 2 equals 9 over 6, right? Which we could simplify. Or let's say, just for fun, that we didn't notice that we could simplify that, and we charge on to the next step, which is getting rid of the dividing by 2 by multiplying by 2. And that would leave us 9 equals, well, 2 is 2 over 1, so that would be 18 over 6, and we get n equals 3. Some of our equations are going to be a bit more difficult than this, but let's take this opportunity to see a different strategy that we can use in those cases. So instead of just dealing with the fractions, let's think about how to make these denominators go away. Think about that fractions are just division, so if we were to multiply, we could potentially use the multiplication property of equality to multiply by a number that would cancel these out nicely. One thing to think about, though, before we do that, is that all of these numbers in this case are different. So if I were going to multiply by 2 as a first instinct to make these 2's cancel out, that 2, as we go through the rest of the equation, isn't going to do the job that we want it to do. So we actually need to think about collectively what we could multiply by that would make all of the denominators go out. So we need a number that all of those denominators go into. That is, we need a common multiple. Least common multiple is the most efficient way to do it. Technically, any common multiple will do, but we're going to strive for the least common multiple. So in this case, 2, 3, and 6, least common multiple is in fact 6. And as we go through here and multiply, it's not like this 6 and this 2 is going to perfectly cancel out. There's going to be some stuff, quote unquote, left behind, right? There's going to be extra factors, right? 6 is 2 times 3. The 2 factor is going to cancel out. The 3 is going to be left behind. We could just go ahead and multiply here and know that the step after this is going to simplify nicely to 3n minus 4 equals 5. But when there are more complicated expressions in our future with other parentheses and more variables and all that stuff, it's probably a little bit easier to do the simplification and reduction as you go. So think about it like this. The 6 and the 2 is going to reduce to be a 3. So when we multiply here, we're going to have a 3 after we do the 6 divided by 2, but then there was the n that is left. Okay? And then the next thing as we distribute here, the 6 and the 3 is going to be what we should probably focus on first, and 6 divided by 3 is 2, but then the 2 from the numerator was still left. And then here the 6 and the 6 do perfectly cancel each other out, but you could also think about it as 6 divided by 6 is 1, and the 5 is left over from before. So this was minus, this was equals, and if you want to do this with simple numbers and just honestly do this calculation as you go, that's totally fine. But what we can do now is take a deep breath that all the fractions are gone and we're left with a normal, sort of easy first degree equation. We can continue on like we saw in the last section with our multiplication and addition properties of equality, and finish this out really quick and get n equals 3. We could then check this work by plugging it back in and seeing if it makes the original equation true. So just to recap some of the terminology I mentioned during the last slide, is a least common multiple is some number that is divisible by each of the things that we want. So in this case, we want the least common multiple of all the denominators, some number that is divisible by all of those denominators. And so our strategy is clearing the equation of fractions by multiplying by that least common multiple. okay? Because we know it's divisible by each of those. That's when we get those nice integer sort of results after we multiply. Okay, because we're doing the least common multiple of denominators, you will frequently hear people say least common denominator. But we're not creating those common denominators and doing the work. We're using that number to clear our equation of fractions. So here's a slightly more complicated example, but a good one to illustrate the fact that when we decide what to multiply by, we don't really want to just multiply and reduce. We kind of want to reduce as we multiply. So let's strive for least common multiple again. Least common multiple is, in this case, 20. So we are going to multiply by 20 on both sides. And instead of multiplying 20 here and saying 80x minus 20 divided by 10 and then simplifying afterwards, I'm saying what we should do, like our last example, is think, okay, 20 divided by 10 is 2. So we have that 2 that's been reduced times what would be there in the numerator. 20 here divided by 4 is 5 times what's in the numerator. And here, there on the right-hand side, we can't forget the right-hand side, very, very important, but in this case, there's nothing to cancel out, so we can simply just multiply. And again, deep breath at this point. We have succeeded in turning an equation with fractions in one step to just a equation, first degree equation that we can solve using our simplification and properties of equality. Okay, so if we do that just to finish it out, this would be 8x minus 2 minus 25x. Be careful that you're distributing the minus. Negative 5 times 2, negative 10 equals negative 60. Okay. And then combining like terms here, negative 17x minus 12 equals negative 60. Use our addition property of equality. Equals negative 48. Divide by negative 17. Oops, I wrote a 4 there. And so then we end up getting x equals, well, a negative divided by a negative is a positive, and 17's prime, so that is already reduced. We get 48 over 17, okay? And thinking back to the strategy of just, oh, how about I just deal with the fractions, get a common denominator and do that work if we did common denominator all the way throughout here, it looks like at some point doing that strategy, we would get some kind of nasty numbers, and dealing with this 48 over 17 for several steps of the problem would not be super great. Let's finish out with a word problem just to continue practicing how to deal with these. First and foremost, we want to define our variables after we read this. A super common one in a problem like this that we've seen on UMTYMP exams in the past is people say things like, A is Angie. And we always kind of joke about like, well, A, the variable isn't the person, Angie. It represents something about Angie. Try and make sure you're clear about that. You're saying in this case that A is Angie's age. Okay, and then her mother's age, we might be tempted to make another variable, but again, first degree equations only have one variable type in it. So when we're talking about her mother here, we want to try and make some conclusion that the sum is 64. So a really, really popular and powerful strategy is to think about the rest, right? So if it's a total of 64 and A is Angie's age, then the rest of that 64 must be her mother's age. And you can find the rest of something very easily by subtracting from the total. So 64 minus A is Angie's mother's age. All right. Then it says in 8 years, Angie will be 3/5 as old as her mother at that time. So there's an equation in there, and we think, okay, 8 years from now, it's not A anymore, but her age would be that A plus 8, and that will be, so that's like is in the future, that's the equals, so is 3/5 as old, that's multiplying by 3/5, So 3/5 as old as her mother at that time. Again, remember that her mother's age 8 years later is also going to be 8 more than it was before. And here's the equation we need to solve. We see when solving this that we're left with a fraction, so you can expect that in a section about dealing with fractions and equations, so that's not a big surprise. Here there is only one denominator, so that whole least common multiple bit is pretty easy. We're going to multiply by 5. If I were personally writing it out, I would write it like this because I don't want to try and sneak a 5 in between that equal sign and that parentheses and make things messy. But this also sometimes presents issues for students because they start to see all of this and are tempted to distribute far more than they need to. Remember, the whole point here is that we were multiplying to cancel out denominator, and that's all that happens here is this divide by 5 and this multiply by 5 cancel each other out. And if you're thinking about, well, what about this stuff? That wasn't separated by addition or subtraction. There's no distributive property going on there, right? These are just two things multiplied together, and if we multiply by another thing, they don't both get multiplied. A quick little example, if somebody asked you to do 2 times 4 times 3, you wouldn't multiply 2 by 4 and then 2 also by 3. You would just multiply these two, get 8, and then multiply by 3 and get 24. Well, that's what's happening here. We're just choosing to multiply with the associative property in the order that we want because the whole point was to cancel out that divide by 5. Okay, so I just wanted to comment on that quick. I will write out the result here. We would have 5a plus 8 equals 3 times, I'll just leave it 64 minus a plus 8. And we're just here looking at a regular, easy first order, our first degree equation that we could distribute, combine like terms, solve, and all of that. I'll leave that to you. We don't need to do a whole bunch of those. But the result here, if you want to pause and try it, is 22. One last comment, though, would be to say, make sure you answer the question. It says find the present ages of Angie and her mother. So we would want to summarize by saying Angie is 22 and her mother, we actually have to answer that as well. So well, we know that the sum of their ages is 64, so she must be 42.